A root that grows across 6 continents produces flour, no grain, no wheat, no annual planting. This root yields 6,400 pounds of flour per acre. Wheat yields 400 pounds per acre. That is 16 times more food from the same land. Humans ground this into bread for 30,000 years. The agricultural industry buried it anyway. By the end of this video, you will know exactly how to harvest unlimited flour from your own backyard using nothing but water and a bucket. In 2010, a team of researchers published findings that rewrote human history. The study appeared in the Proceedings of the National Academy of Sciences. Anna Revedin and her colleagues had examined ancient grinding stones from 3 archaeological sites, one in southern Italy, one in Russia, and one in the Czech Republic. These stones dated back 30,000 years, and embedded in their surfaces, the researchers found something unexpected: starch grains, thousands of them, preserved for 300 centuries in the microscopic crevices of the rock. The grains came from plant roots, specifically from a wetland plant that still grows across the northern hemisphere today. This was not decoration. This was not accident. The wear patterns on those stones showed deliberate grinding motions. Our ancestors were making flour, they were making bread, and they were doing it 20,000 years before anyone planted the first wheat seed. Think about what that means. The standard story of human civilization starts with agriculture, the Fertile Crescent, domesticated grains, and settled villages. But these grinding stones predate all of that. Women in Ice Age Europe were processing plant roots into flour while mammoths still walked the earth. They had sophisticated food technology. They understood carbohydrate extraction, and they passed this knowledge down for hundreds of generations. The archaeological evidence does not whisper this, it screams. When researchers identified those starch grains, they found a match. The plant was Typhoeaceae. You know it by another name, cattail, the brown, hot dog-shaped plant growing in every marsh and roadside ditch across the continent. You have walked past it 1,000 times. You probably thought it was a weed. Your ancestors thought it was dinner. This was not a regional food source. Indigenous peoples across North America relied on cattail as a staple crop. The Apache, the Pomo, the Navajo, the Cahuilla, the Lumbee, tribes from the Atlantic to the Pacific processed cattail rhizomes into flour for millennia. Around Lake Titicaca in South America, the same traditions developed independently. In Australia, the Noongar people harvested cattail roots as a primary carbohydrate source. Different continents, different cultures, different languages, same plant, same solution. This was universal human knowledge. And somehow, in the span of a few generations, the modern world forgot it completely. Now here is where the numbers become difficult to believe. A study conducted near Wolcott, New York, measured cattail productivity under optimal conditions. The researchers harvested 140 tons of rhizomes per acre, 140 tons. To put that in perspective, the average potato yield in the United States is about 20 tons per acre. Cattail produce 7 times more root mass than America's most productive tuber crop. When you process those rhizomes into flour, the numbers remain staggering. 1 acre of cattails yields approximately 6,475 pounds of flour per year. 1 acre of wheat yields between 200 and 400 pounds of flour. That is not a slight advantage. That is 16 to 32 times more flour from the same amount of land. The starch content explains why. Cattail rhizomes contain up to 70% starch by dry weight. That rivals pure cornstarch. The caloric density matches wheat flour almost exactly at 266 calories per 100 grams. The protein content compares favorably to rice and maize, and unlike most wild foods, cattail flour contains meaningful amounts of manganese, vitamin K, magnesium, and dietary fiber. A wartime survey conducted by the United States government mapped cattail distribution across the country. They found 140,000 square miles of cattail swamps. That is an area larger than Germany, growing wild, producing no economic value, classified as wetland habitat, or worse, as invasive nuisance vegetation. Meanwhile, the global flour market generates $260 billion annually. Wheat flour alone accounts for 44% of that market. Farmers buy seed every spring. They buy fertilizer, they buy pesticides, they buy irrigation equipment. They harvest once per year, then they start the cycle again. Cattail does not fit this model. Plant cattail once and it spreads on its own through underground rhizomes. It requires no fertilizer because it thrives on nutrient-rich runoff that would kill other crops. It requires no irrigation because it grows in standing water. It requires no pesticides because few organisms attack it. And it cannot be patented because it is a wild plant in the public domain. A single planting becomes a permanent food source. A permanent food source generates zero recurring revenue. Zero recurring revenue attracts zero corporate investment. Zero corporate investment means zero marketing budget. And zero marketing means 3 generations of humans grow up without ever learning that the most productive flower plant on earth grows in the ditch behind their house. This is not conspiracy. This is economics. The global seed industry generates $60 billion per year. That business model requires farmers to purchase new seed annually. Hybrid varieties, patented genetics, Terminator technology prevents saving seed from year to year. The entire structure depends on repeat transactions. A plant that spreads itself for free threatens every link in that supply chain. Compare the research funding. Search any scientific database for wheat flour studies and you will find tens of thousands of papers. Universities compete for agricultural grants. Corporations sponsor research that supports their products. The knowledge base grows every year. Search for cattail flour studies and you will find a few hundred papers. Most originate from Poland or Brazil or Malaysia. Western agricultural institutions produced almost nothing. The plant that feeds itself was deemed economically worthless because it could not generate shareholder value. Look at what happened to American wetlands over the past 2 centuries. European settlers arrived and found marshes covering vast stretches of the continent. They drained 90% of those wetlands for agriculture. They converted cattail habitat into wheat fields and cornfields and soybean fields. Crops that require annual inputs. Crops that generate annual sales. Crops that keep farmers dependent on the industrial supply chain. The cattails that survived were reclassified, no longer a food source, now an invasive species, something to be controlled, something to be eradicated. Government agencies publish management guides on how to kill cattail populations, herbicide recommendations, mechanical removal techniques, controlled burns. They are spending money to destroy a plant that produces 30 times more flour than the crops they replaced it with. But the research that does exist tells a remarkable story. In 2012, Brazilian scientists published a study in the journal BMC Complementary and Alternative Medicine. They fed cattail rhizome flour to laboratory rats with induced colitis. The results showed significant protective effects against intestinal inflammation. The flour contained compounds called flavonoids and saponins that reduce tissue damage by measurable amounts. The researchers concluded that cattail flour could serve as a dietary supplement for preventing and treating inflammatory bowel disease. A 2014 study from Poland analyzed the molecular structure of cattail starch. The researchers found that the starch granules had properties suitable for food processing applications. The composition matched emmer wheat flour closely enough to function as a direct substitute in traditional recipes. This is peer-reviewed science, published in respected journals, confirming what indigenous peoples knew for millennia, and it sits unread in academic databases while grocery stores charge premium prices for ancient grain alternatives. The plant does not care about market dynamics. Cattail grows in standing water from a few inches to 4 feet deep. It tolerates brackish conditions. It thrives in disturbed soils. It colonizes new wetlands through wind-dispersed seeds that travel miles from the parent plant. A single seed head contains up to 200,000 seeds. Each viable seed can establish a new colony. Each colony spreads through rhizome networks that expand outward year after year. You cannot stop this plant. You can only decide whether to eat it or ignore it. Harvesting requires nothing more than a shovel and patience. The rhizomes grow horizontally through mud and sediment at depths of 6 inches to 2 feet. Late fall through early spring offers the highest starch content because the plant stores energy in its roots for winter survival. Pull the rhizomes from the substrate, wash off the mud, peel away the fibrous outer layer. The white inner core contains the starch. Traditional processing involved drying the peeled roots and pounding them with stones. The same technique is preserved on 30,000-year-old grinding surfaces in Italy, Russia, and the Czech Republic. Modern foragers use simpler methods. Grate the fresh rhizomes into cold water. The starch sinks. The fiber floats. Pour off the fiber and let the starch settle. Dry the sediment and you have flour. One afternoon of work produces enough flour for weeks of bread. The rhizomes regrow after harvest. The colony expands whether you want it to or not. A single backyard pond becomes a perpetual flour source that requires no replanting, no maintenance, and no annual expense. You can use cattail flour as a direct substitute for wheat flour in most recipes. It works for flatbreads. It works for pancakes. It works as a thickener for soups and sauces. Some foragers blend it 50-50 with conventional flour. Others use it straight. The flavor is mild and slightly sweet, with none of the bitterness that ruins other wild food experiments. The pollen works too. In early summer, cattail produces massive quantities of bright yellow pollen. Shake the flower heads over a container and you collect a protein-rich powder that functions as a flour supplement. One plant, multiple food products, 0 inputs required, a pond, some patience, free flour forever. Your grandmother's grandmother knew this. Her grandmother's grandmother knew it too. 30,000 years of unbroken knowledge is available to anyone willing to get mud on their boots. The flour industry will not tell you about this plant. The seed companies have no product to sell you. The agricultural extension offices receive no funding to research it. The knowledge exists in scattered papers and forgotten archives and indigenous oral traditions that Western science spent centuries dismissing. But the plant remains, growing in every roadside ditch, every farm pond, every wetland margin, every neglected corner of every continent in the temperate zone. $260 billion of flour moves through the global economy every year. Farmers spray pesticides and spread fertilizer and pray for rain. Grain elevators fill and empty and fill again. Trucks carry wheat across continents to mills that grind it into the powder that becomes your bread. Meanwhile, this root grows wild within walking distance of nearly every human settlement on Earth. It yields 16 times more flour per acre than wheat. It requires no planting, no watering, no fertilizing, no harvesting equipment, no processing facilities, no supply chain. It simply grows. It has always grown. It will keep growing long after the wheat fields go fallow and the grain silos rust and the flour mills close their doors. The only question is whether you will use it.